Hi, my name is Octavia Martin, and today I'm going to talk to you about brain plasticity. The brain is really fascinating because it serves as a highly organized and complex dynamic system that is constantly reshaped throughout a lifetime. Different experiences create neural connections that reorganize the brain. This capacity for the brain to adapt itself to various stimuli is referred to as neuroplasticity. Genetics, the environment you're brought up in, and even your own behavior all play a role in how your brain develops. In newborns, brain plasticity is very important because it is used to sort through the abundance of sensory information that newborns are flooded with. They receive all this data from their sense organs and need to transfer it to their brains for processing. This is done via the creation of neural networks. Nerves make connections with one another and transmit impulses to the brain with this new information. The brain grows rapidly over the next few years with more and more connections being made. As the child brain continues to develop, so-called weak connections are actually deleted. This increases the efficiency of the neural network because the brain connections that are activated the most are the ones that are preserved. This process is called synaptic pruning. Synaptic pruning is just like pruning a bush. Neural connections are removed from the brain, reshaping it, just as branches are removed from a bush to give it a desirable shape. In adulthood, brain plasticity is at work all the time, whenever something new is learned or memorized. In fact, becoming an expert in a certain field will cause the associated areas in your brain to grow. London taxi drivers, for instance, have been found to have larger posterior hippocampi than bus drivers do. This is because taxi drivers have to retrieve complex spatial information in order to determine the best route to take, whereas bus drivers are required to follow a specific set of routes. These kind of changes in brain area have also been observed among bilinguals and musicians. An especially interesting and important aspect of brain plasticity is its ability to compensate for impaired or lost function after brain damage. A certain brain function located in one area can actually move to another region of the brain in response to injury or experience. Examples of this are seen among epileptic patients who undergo hemispherectomies to reduce seizures. Regions from one hemisphere of the brain are removed and the corpus callosum, which connects the two hemispheres, is cut. Often, especially among children, the remaining side of the brain takes over the tasks that were previously executed by the removed portion. And this is a life-saving aspect of neuroplasticity. Ultimately, neuroplasticity shows us that the brain is extremely malleable and constantly changing. Since the brain controls everything we do, harnessing its plasticity could be an enormously powerful tool.